Okay, we're going to go over the homework that was due, or that is due on Friday, October 30th. So this is practice A. This is the side, obviously this says practice A. I'm not going to go over all these. Some of these you should be able to do. There are a couple words here that may be unfamiliar to you that I will go over with you. So, number one, you should be able to do, I'm not going to do that. It's referencing this diagram right here. Number three should be something you could do. Now, this remote interior, in your notes, we classify these as non-adjacent. So, if you look at angle 6, that's this angle right here. It's actually an exterior angle, so that gives you one of the answers for number one. But it's an exterior angle, and the remote interior angles, or non-adjacent, would be the ones that are not next to. Remember, we talked about in class that adjacent means next to, non-adjacent means not next to. So number 5 is next to, so the non-adjacent or remote interior angles, as this worksheet puts it, would be 2 and 3. So our answer for number 2 would be angle 2 and also angle 3. All right, number 4 you should know how to do. We know what type of triangle has angles that are 60 degrees. We talked about that. Number 5 should be a gimme. The acute triangles of a well, you should be able to do this as long as you remember what acute means. That means less than 90. And complementary means add up to 90. If you remember those two things, there's only one type of triangle that can have the acute angles add up to 90 degrees. So what type of triangle is that? The measure number 7. Let's see. And number 7 you should be able to do. We talked about that. That's one of our theorems we talked about. So again, remote interior would be non-adjacent. So if you look in your notes and you see non-adjacent, that's the same thing. That's what they're classifying as remote interior. So non-adjacent. So in your notes, you should know the measure of a what of a triangle is equal to the sum of the measures of its remote interior angles or non-adjacent interior angles. All right. And remote is really what it goes with non-adjacent. And up here again, remote is what can be replaced with non-adjacent. So non-adjacent interior angles and remote interior angles, same thing. All right, let's look at these other ones. These should be gimmies. These are not ones that I'm going to go over. And so at the end of that, these are ones you should be able to do. 14 might be a little difficult, but just try it. All right, let's go to the other side. A little bit more difficult, but still doable. So you need to read this very carefully. So I'm going to read it just so we get a good sense of what's going on. An area in central North Carolina is known as the Research Triangle because of the relatively large number of high-tech companies and research universities located there. So we're referring to this diagram over here. Duke University, the University of North Carolina, Chapel Hill, and North Carolina State University are all within this area. The Research Triangle is roughly bounded by the cities of Chapel Hill, Durham, and Raleigh. From Chapel Hill, so let's look at Chapel Hill. That's a city in North Carolina. The angle between Durham and Raleigh measures 54.8. So this angle here would be 54.8 degrees. All right? From Raleigh, the angle between Chapel Hill and Durham measures 24.1. So now I'm going to move this. I'm going to make sure that this 54.8. So now it says from Raleigh. Use a different color here. The angle between Chapel Hill and Durham measures 24.1. So we have this angle, and obviously it looks like this angle here is 24.1 based on the reading, 24.1 degrees. And find the angle between Chapel Hill and Raleigh from Durham. Well, by process of elimination, we know that this is the angle they're looking for. You should be able to do that based on everything we know about triangles. All right, you should be able to do number 2. You know it's a right triangle and the acute angles are congruent. You should be able to tell me what the other angles are. That should not be an issue. Let's see here. I'm going to pause this for a second so you guys keep working on it. All right, let's look at number 4. This is part of the, hold on, I'm going to have to pause that. Okay, we're going to look at number 4. I'm back. I got a phone call, so try and go through the rest of this. 3 and 5 and even 4, you should understand from the directions. It says the measures of one of the acute angles in a right triangle is given. Find the measure of the other acute angle. Well, if you have a right triangle, you know one of them's 90 degrees. So 3 and 5 should be easy. Number 4 might be a little tricky. You know it's a right triangle, so you know one of them's 90. So the one right here is 90. And then you know one of them is represented by 90 minus z. So what is the other one? Well, let's think about that. What does this one have to be? So think about that for a second, and I'll come back. Okay, I put up another triangle. Then I'm going to circle in green. Now, what if I gave you this triangle that I just circled in green, and I said that this angle over here was z degrees? Now, what would this one be? Well, remember, the interior angles of the triangle have to add up to 180 degrees. So that means that this angle, which is we know is 90, and these other two angles have to add up to 180. But we also know that if this one's 90, then these other two have to add up to 90. They're actually complementary, which will actually help you out with another piece of your homework. But these two angles are complementary. So if this one is z, and they have to add up to 90, that means this top one has to be whatever z is taken away from 90, or 90 minus z, right? If I give you, let me get rid of this. If I give you a triangle here, and you know this is 90, and you know that this is 30, then this one just has to be 90 minus 30, which is equal to 60. If I gave you a right triangle here, and this was 90, and this was 45, then this one would have to be 90 minus 45. So if I give you a triangle here, and this is 90, and this is z, then this one has to be 90 minus z. So if you go up to our question, it was actually given, you were given that this one is 90 minus z, so then what does this one have to be? Well, it just has to be z. Hopefully you can see that based on the diagrams that I drew. That's a little confusing, but hopefully you understood that. And if you don't, well, try thinking about it. Ask me any questions. That's a hard thing to explain, but hopefully you understand that. All right, let's go now to erase this. Number 8. We should be able to do number, let's see. Okay, so you should be able to do 6 and 7. remember what we know about angles. These are going to have a particular relationship which will allow you to get this, because you know these are the same. Those sides are the same. That makes this an isosceles triangle, which we know something about the angles, so all of that should help you with that. This one, we have this exterior angle, and we have our theorem about those two non-adjacent interior angles, or remote interior angles, as the worksheet said. So the last one I'm going to do is number 8. So we can draw a triangle. In triangle LMN, the measure of exterior angle at N, of an exterior angle at N, it's been a long day, measures 99 degrees. So I'm going to draw a triangle. L, M, N. It says the measure of an exterior angle. So exterior angle would be on the outside, 99 degrees. So the measure of angle L is 1/3 x. The measure of angle M is 2/3 x. Find angle L, angle M, and LNM, which would be this one. So we need to find these blue ones. Angle L, angle M, and LMN, or LNM. Alright, so we know that this exterior angle is equal to the sum of the two non-adjacent interior angles. So we know that 99 is equal to, so this is equal to the sum of this angle and this angle. So 2/3 x plus 1/3 x. Alright. So let's solve this. 99 equals, we can combine these like terms. 2/3 plus 1/3 is just 3/3 x. We know that 3/3 is equal to 1, so 99 equals 1x. So we've already solved it. Pretty easy. X equals 99. So angle LNM, which is, actually, you know what? We didn't even need this one on the outside. We don't need, because LNM is actually on the inside. So we need this one, and this one. We don't need the one on the outside. We need the 3 interior angles. So we found x. X is 99. So if I want to get angle L, I would just plug this in for x. So 1/3 times 99 is equal to, hopefully you know this, try it before you see the answer. 1/3 times 99, that's the same as 1/3 times 99 over 1. When you're multiplying fractions, multiply the top and multiply the bottom. So this equals 99 over 3, which is equal to 33. So this angle is 33 degrees. So that's angle L. So angle L equals 33 degrees. Then I can plug it in here. So 2/3 times 99. And that's the same thing. That's going to be 2/3 times 99 over 1. We can use a little shortcut. We can actually cross cancel. So 3 goes into 3 once. 3 goes into 99 33 times, which equals 2 times 33 is 66 over 1. So 66 degrees for angle M. So angle, so the measure, let me write measure, will be consistent. So the measure of angle M equals 66 degrees. And angle LNM. So a couple different ways we can do this one. We know that this angle I'm about to put in green and this angle add up to 180. That's one thing. Also, we know the interior angles all add up to 180. So either way, our LNM, which is this one, has to be 101, right? Not 101. What am I talking about? Because what plus 99 gives me 180? 81. So angle LNM, measure of angle LNM equals 81 degrees. that right? That all looks right to me. Okay, the last thing I'll say about 9 and 10. If you look at number 9, I don't have it up here, but if you look at it, those angles that they're pointing to, and I'll draw a little quick diagram. On number 9, they have something like this. Well, that's close enough. That's not a great job, but we have two angles here. These are actually, even though it does not say those lines are parallel, these two, that's a problem I should have had. I should have said those lines are parallel, but those angles are actually alternate interior. If you consider this line going through, you have this line, this angle, and this angle. Actually alternate interior, so we know something about those two angles. And on number 10, those two triangles are something to one another. So you can solve for n and find the actual angles, measure of angle T and V. So try and do those, the bottom ones. Try your best on those. Number 11, draw a diagram. Number 12, that might be kind of difficult. We haven't talked about that too much, but see what you can do on that one. All right? And that is the video for today.